Let's address the recycling and recovery of the incoming tsunami of end-of-life waste electronics that is heading towards us so that we don't drown. Developing a strategy for the methods to manage the mountains of e-scrap we are generating is paramount to achieve or maintain sustainability. In an effort to understand some of the key fundamentals that drive the waste and recycling industry, we have developed a website, waste.net, to act as a tool to assist in grasping the 4R strategy of reduce, reuse, recycle, and recover. Within the 4R's recycling sector, e-scrap may be one of the largest challenges our generation faces, that we must overcome. Tackling the recycling and recovery of e-scrap is the task at hand. In the age of electrification, we all collectively have adopted the use of countless numbers and types of electronic devices and gadgets. It is incumbent upon all of us to accept the responsibility to manage the waste we generate from this evolution. With the proliferation of microelectronics, it has become difficult or impossible to manually dismantle and separate the small components and trace elements contained in these complex devices. At this point, we have developed a comprehensive strategy to address the issue of e-scrap. This is a step-by-step approach for the recycling and recovery of virtually all types of e-scrap in an environmentally sustainable fashion. The first receiving triage stage performs a crude separation to group similar materials together, and to identify and remove any potentially hazardous items. This primary separation establishes the pathway or route the different groupings of materials will follow. Each of the following steps are designed to whittle the stream of materials down by selectively removing sorted recyclable commodities for sale at each step, and the balance of the volume of materials moves on to the recovery process for further selection, concentration and refining, and ultimately for sale. Any materials not diverted at the triage stage, and that are suitable, which represents the bulk of the incoming volume, will be processed through a primary size reduction stage, to be reduced into a -6 inch or an equivalent -15 centimeter size. This -6 inch material will pass through a magnetic separation to remove the ferrous metal fraction, which is sold as scrap steel. The balance of the material will be separated into 4 designated size streams. The 4-stream loop is a size classification system using the descriptive terms of minus to equal less than, and the terms plus to equal more than, in order to define the size range. Let's delve deeper into the 4 loops. Loop number 1. -6 inch. This stream contains the -6 inches, or less than 15 centimeters, down to a size of +2 inches, or larger than 5 centimeters, as a fraction of mixed e-scrap that is subjected to the identification and segregation process for clean commodity extraction. This 6-inch size fraction is suitable for density separation by a cyclone or strong airflow current, which accommodates easy separation of pieces of an individual commodity with manual, mechanical or robotic methods. Any unsorted material remaining at the end of this first 6-inch fraction path is sent into a secondary size reduction step, and is reduced into an under 2-inch or smaller than 5 centimeter fraction. This material is fed back and regenerated into the sizing process to be reduced and divided into the remaining 3 size fractions. Loop number 2. -2 inches. This fraction contains a -2 inch, or smaller than 5 centimeter, down to a size of +1/4 inch, or larger than 0.635 centimeters, mixed material fraction, that may be segregated to extract any clean commodity. This size fraction may be too small or tedious for efficient manual separation, but may be ideal for automated robotic sorting en masse. Any remaining unsorted material at the end of the -2 inch or smaller than 5 centimeter path is further size reduced in a 3rd step shredder, to a size under 1/4 of an inch, smaller than 0.635 centimeters, and that material is returned to the size classification screening process and divided into the 2 remaining fractions. Loop number 3. -1/4 of an inch. This is a -1/4 inch, or smaller than 0.635 centimeters, down to a size of +10 mesh, or a larger than 2 millimeters fraction, that is now a freshly liberated material, from which clean commodity may be extracted. This fraction may be the sweet spot for flat vibrating plate air separation and is also ideal for automated mechanical metallic and non-magnetic fraction segregation. Any of the contaminated or mixed remaining -1/4 of an inch or smaller than 0.635 centimeter fraction may be pulverized or milled in a hammer or ball mill, and returned to the size classification stage. Any materials that have been milled and that do not pass through the -10 mesh size may then be isolated, identified, and sent for designated processing. Loop number 4. Fines. This material is a -10 mesh powder, smaller than 2 mm, or a particle size referred to as fines, that have been freshly liberated and is prepared for extraction, and may be gravity separated or electrostatically segregated into clean commodities. This size of particle in the fines fraction may be ideally suited for vibrating water table density separation or a sluice-style light and heavy separator. The remaining nonmetallic fines, or residual mixed fraction, may be directed for thermal reduction, at which point the hydrocarbons or any organic volatiles are dealt with for disposition in the Recovery 2.0 process. The segregated or mixed metallic fines fraction typically contains the highly desirable strategic and exotic or trace heavy metals elements, which are commonly prepared for hydrometallurgy or electrochemical refining. The combined recycling and recovery effort systematically uses a concentration and selective extraction approach to manage virtually all of the e-scrap. We intend to cover some other aspects of the waste electronics and electrical equipment field at some point in the future. Until then, please feel free to reach out to us at your convenience. Waste.net provides a neutral platform to assist in finding a market for scrap, waste and byproducts, with the goal of matching waste material generators directly with beneficial users of those materials. By connecting market participants, we foster collaboration and promote environmental sustainability. Please feel free to visit us today at www.waste.net.